Welcome to this comparison of SCS results with an example taken by AISC Seismic Design Manual, 2nd edition. Example 443, page 494, deals with baseplate design. We have started SCS module for baseplate to recreate the example with the software. Let's follow LRFD method in this example, but the same can be done with AISD. General options seem to be all okay. Let's input loads as per example data. Actually, for the base plate, as the book explains, shear should be the greater of the required shear strength determined from load combinations including the amplified seismic load or the required column strength, which brings to this formula, and the shear to be applied for the base plate calcs of 190 kips. Please notice that SCS can take the input also as a formula if value is introduced by equal. The formula will also be stored in SCS memory, and once the cell is clicked, the formula is shown. Column size is W14 by 176. If we try to select from the menu, different families of members will show up at first. To make our selection easier, let's filter off some European type profiles. Then we choose material. Clicking on this little button, we can check out member properties. Bolt size, as suggested by the example, is to 1/4. This size is not in the database, then we have to edit it. As explained in the help, AGR is the bolt gross area and can be omitted as input, while ARES must be input. Let's input 80% of the gross area as used by AISC, but a good approximation generally speaking. Let's also input material for plate, concrete and grout thickness as per example data. Square root of concrete area ratio is set to 2 as per manual hypothesis. In the manual, phi coefficient is taken as 0.65, so we override the default SCS value. To match example geometry, let's move to the Geometry tab, where A1 value must be set to 4.4 inches, A horizontal plate 4, B1 to 12, and A vertical plate top to 4 inches. Those values recreate the same conditions of AISC Seismic Design Manual. SCS gives a value of 326 inches as minimum plate thickness compared to 327 inches by the manual. The reason for this minimal difference, 0.3%, is just about decimal rounding. In addition to AISC Design Guide 1 solution, which is for only one row of bolts, SCS can provide solution when more rows are used. Anchor rod, combined tension and shear is checked too by SCS if we set both group eccentricity to 219 inches as in the example. In the book, the combined tension and shear design ratio is 73%, while SCS value here looks a little different. The reason is that our default options consider also friction as resisting shear. If we switch option to anchor bolts only, we get 73%, same exact result of book. Also, welds can be set up to match example data. Parts of the example that are not automatically checked by SCS are washers, anchor rod head plates, and concrete checks for shear and tensile loading according to ACI.